All right, so here we have a particle that moves along the x-axis so that its velocity at time t is greater than or equal to 0 is given by this equation. Part A. There's one time t is equal to tr in the interval from 0 to 2 when the particle is at rest, not moving. Find tr for t between 0 and tr. Is the particle moving to the right or to the left? Give a reason for your answer. Yeah, sure, it will. So we can just graph this because we are allowed a graphing calculator on this problem. So let's graph this, and we want to see when the velocity is 0 and see what's going on, see if it's positive or negative before and positive or negative after. So we essentially want to have the intercepts. And here we go. Look at that. I already have it done. Let's zoom in, get a closer look. Center. Come on. All right, so let's analyze. 0. So we have a 0 at 1.4256. Let's try a little sketch here, actually. Or I guess I can draw it up here. And then I could look at where the other one is, just just for fun. Other one's at 2.8832. 2.88320. This is the graph of v of t. Now, since it's positive before and negative after, that means it was moving to the right before and then moving to the left after. So then before this point, it was moving to the right because it was positive. So we can probably just write that for our answer A. So let's put that A is to the right. Since V of t is greater than 0 for t between 0 and tr. Part B. Find the acceleration of the particle at time t equals 1.5. Show the setup for your calculations. Is the speed of the particle increasing or decreasing at time t equals 1.5? Okay, so all we got to do here is find the derivative of the particle, or find the derivative of velocity and evaluate it at 1.5. So we're essentially finding v of 1.5. And so let's go to our calculator. Numerical derivative at a point. Wow, it's -1 exactly. Who would have thought? Now, at -1, we want to if we want to well, not at -1, the acceleration is -1, and we want to know if the velocity at this point at 1.5 is negative or positive. If it's the same side, if it's the same sign, that means they're both going to be going. They're both working together. So in this case, if they're both negative, they're both moving. It's accelerating to the left, and so we will say then it's increasing. It's increasing because they're both velocity and acceleration are both negative at t equals 1.5. You're probably right. Well, I mean, not that this is being graded, but since v of t and a of t are both negative at t equals 1.5. Part C. Position of the particle at time t is x of t, and its position at time t equals 1 is x of 1 equals -3. Find the position of the particle at time t equals 4. Show the setup for your calculations. Okay, so all we have to basically do is look at this what the displacement is from 1 to 4 and add it to x of 1. So the position x of 4 is equal to -3 plus integral from 1 to 4 of v of t dt. We again just can evaluate this. So 1 to 4, the natural log of x squared minus 4x hold up. X squared minus 4x plus 5 minus 0.2x. About 0.19, which isn't that much, I guess. And then we'll take away 3 from that. We end up with about negative 2.80289-ish. Or let's just leave it at 88, actually. All right. Now, last one, find the total distance traveled by the particle over the interval from 1 to 4. Show the setup for your calculations. Okay, so for this, you have to make sure you are careful to not just integrate, because when you integrate, that will just give you the displacement over some interval. So it's possible that it could be 0 because maybe it goes back to the same position, but that doesn't tell you the distance traveled. So what we want to do is take the absolute value of the integral, or in this case, we're going to have the integral from 1 to 4, and we're going to have the absolute value of v of t dt. That way, it's going to calculate how it's going to treat everything as a positive quantity, so to speak, and it's going to give you how far it traveled over that interval. So you can also do this in your calculator. Well, depending on the calculator you have. I have one that you can do that in. And we're going to go bust out the absolute value symbols. Here we go. Natural log x squared minus 4x plus 5 minus 0.2x ex. Here we go. 0.95881 on all that. 0.9581339932246. All right, so there we go. That's it for that. So I hope that helps, and I hope those are correct because the solutions haven't come out, but I'm pretty confident in this. But again, leave me any questions and you have in the comment section. I'll try to get back to you as quick as I can.